The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update. Today is Thursday, October 21st, 2021. We're over 3 weeks into Kilauea's newest eruption here, and the eruption is still going. I'll show you guys some views taken from the public overlook here in Hawaiʻi Volcanoes National Park that we'll start off with today. I'll just let it loop while we introduce the program today. We'll start off talking about what you can see from the national park. We will discuss viewer questions as we go about what can be seen, answer some common lava viewing questions. Dana will be collecting questions in the chat and manning the chat, so let us know if you have any issues with our audio or video. He will be checking on that, mahalo Dane. And he'll be answering what he can in the chat and collecting other ones for us to discuss either along the way or during our mid-segment break here. So we'll talk about that. We'll talk about the data and what it might be telling us. There's been a little bit of a change in the direction of inflation of the volcano. So we'll consider what that might be due to, where it might come from, that kind of thing. And then we'll make sure that we cover all the USGS videos and USGS photograph, and at least some detail, picking out the highlights and the important data that's included in the captions there for you guys. And then as a final tease, there was a Volcano Watch released today by the USGS, which touches on the topic of giant landslides and mega-tsunami, both starting off at La Palma and the Canary Islands in particular, but it will also tie it back into what they've said in the past about that kind of catastrophic event potential in Hawaii as well. So you have to stick around.
Yep, and we know how the internet loves those mega-tsunami things.
Yeah, so if you guys want to hear that, you'll have to stick around to the very end, and we probably will go on for a while today, so we'll try to front load it for you guys who are interested in more of the shorter what's going on now, and then if you're still interested, then stay with us as long as you can. All right, so that said, here is a view of a video we released earlier today on our YouTube and Facebook platforms. Video that I shot over this past week from the public overlook at Kanakakoi with a big zoom lens, grant you, but it gives you some idea of the kind of activity that's been present there at that west vent. Combining both still video here as well as some time-lapse animations here, so you can get some idea of the kind of activity. A lot of times fountaining recently in the last week or so has remained below that rim of that vent, but it has been splashing upwards, and occasional bursts of gas will propel it upwards. Maybe not quite twice as high as that cone, but perhaps nearly so. And this morning, you guys will see here, this time-lapse will shift to the full moon that was setting this morning as the sun rose over Halemaʻumaʻu to bring you guys current. There it is, a little current event here, so a little loop back around, you guys can see. I'll narrate it for you guys there, right? So view panning across a whole lava lake. In the darkness, you can see that glow coming through the crust, more so than you would in the daytime, where it looks more of a silvery and not quite as bright. You might see the red in between where the lava channels are exposed, but it won't look quite as red. You can see that a little bit in this time lapse as it comes from dawn into daybreak. Still, great viewing. There's one of those high bursts of lava. You can see how high it's reaching above the cone there. That was more typical back on October 16th and 17th when these videos were taken. You can see this really, really tall burst there. And it seems like that was kind of spurting at that point in time. Really, we had reports. The last report of a real big spurt was October 13th, where it was reported the lava was up to perhaps 100 feet high. 30 meters or so. And since then, it's been reported mostly in a 5 meter to 10 meter range, right? So more like 15 to 30 feet high fountains. Still occasional bursts, but overall, it seems like lower, apart from a couple of day interval in there where it really seemed like it peaked, right? So it peaked a little bit on the 13th, peaked a little bit on the 16th and 17th. And more recently, it's back down within that walls of the vent there. So interesting to note that those fountain heights and compare them, right? You can see another interesting aspect here is this exit point from the vent right there. Oh, no, it didn't go where it was supposed to, so let me clear that. And let's let it loop around here again, but there, that exit point to the vent right there. Let's give me the arrow. So it's like a rapids. It's been changing shapes. At one point, it crusted over. It made a little bridge right there. So the lava was going through that little tunnel, but it seems like those pieces break off, and the whole vent has been changing shape and height, perhaps as well. So to examine that a little bit, we'll look at some of the USGS photographs and captions here to unravel the height of this cone and how it's changing, and we'll find this is a little bit more complicated than it appears at first glance. All right, so moving on. This photograph from October 15th, I pulled it out in particular because of its caption. You can see this is a view taken from a helicopter. That's how they got this low angle view into the mouth of the vent there, right? You can see the fountain clearly below the upper rim, upper wall of that crater, and facing on this little rapids that's flowing out, right? So it's like a perched area right in here that might be a few meters, 10, 15 feet or so higher than the rest of the lake, perhaps, according to some of the captions. And let's see what we can see here if we let it scroll down. So a short spillway through a gap in a cone and into the lake. For scale, the maximum height of the cone above the lake is 25 to 30 meters, about 80 to 100 feet. So we have heard this 30 meter, 100 foot value before in some of the previous captions, right in there. And that's where we will be focusing on this range. We've been seeing reports more of the 30 meter variety, 100 foot variety in previous reports, and it seems like we're shifting more towards the 25 meter, 80 foot height of the cone. And perhaps that's some change of the cone, or perhaps it's more than that. So let's see if I can click there. And let's go to the next photograph here. So this photograph of fountain as well is talking about the 25 meter, 80 foot high height of the cone, and its caption there. So you can see that shift to that. And you can see one more photo I'll pull out with a caption that's interesting about the cone height here. Another fountain, you can see it's peaking. You know, it's kind of a oblique perspective, so you can't exactly tell, but a little bit below the rim of that cone, we'll say, right? Something like that. And in that case, they were saying the cone grew 6 meters in 24 hours between October 15th and 16th. That would be 20 feet, 6 meters, 20 feet. So the fountain here measured at 20 feet, 66 feet in height on the morning of October 16th. And so that's in that range of those taller fountains that were starting to burst above that vent there. So perhaps the vent is changing, it's growing, and maybe it was underestimated. They're saying it's growing more, but they're giving a lower value, and there's a reason for that, and that's because this whole edifice is actually rising up, as we'll show you guys later in a thermal imagery coming up shortly. But to continue our first update here, I want to continue first phase here, continue reviewing what's visible from a national park. So made this little loop of what's visible from Waikahuna Overlook, which is just east of the former Jogger Museum here, and you can see the view there. It's, you know, a very big zoom lens. It's kind of blurry. You might see a little bit of lava flow going out, but you're really just seeing these overflows from that edge of the lava lake, really. It's not the same as seeing the vent from the south side, but there is view visible from the north side. You can see there kind of a little bit of the glow on the horizon up there, and it's a really small area, but zooming way in, that's what you can see. And this area is the area of more interest because this is that southeast side that's next to that lowest ledge, the lowest rim of that crater. So this is the spot where it will likely start lapping out of the crater and onto that lower ledge. Now it's tempting to say it's going to spill out, but because it's a funnel, it really can't spill out. It can just start lapping into a wider diameter where it flares out above that, right? So it's going to be a slow process. It's trying to overlap its way up this ramp, and so it'll slowly expand, but it has room to grow there, and that's the interesting thing there. So that's the Waikahuna perspective, which I imagine if that starts lapping up will become more popular, although not seeing a fountain, of course, is one of the drawbacks. The benefit, of course, is that that trail is only 1/8 of a mile over pavement, as opposed to having to hike 1 mile, of which 3/4 of it is on the road on the south side, but then maybe 1/4 of it is over the fresh cinders of, I call them fresh, but they still look fresh, of the Kīlauea eruption in '59. So kind of crunchy, a little bit loose rock underfoot kind of trail over there. So those are the common questions of viewing here. So we're going to explore this overflow question a little more. If we zoom in on the Kilauea camera here, we're looking at this little area as a possible overflow spot right there. You can see there's a little bit of a cliff, but it's really not that wide, right? It's really decreased over time substantially. So through that gap, we're looking mostly at this corner of the lava lake over here in the southeast, across that gap. So as the whole level rises, you'll see more and more lava, this whole azimuth right here, and then perhaps spilling over a little bit in this area right there. And that's the viewpoint from that area. So if we scroll to the last 24-hour time-lapse animation, you might can see the distance below that rim right there, and that lack of glow or activity in the short term in that area there. So it's still rising. It's not quite visible from here as easily, so we'll have to explore other avenues of documenting that. So we'll move on to looking at first the B1 time lapse, and this is compiled by Dane. I sped it up a little bit, and we also have to thank Bob Martin for the image collection as well. Mahalo, all you guys. So we do have the automatic 24-hour USGS time lapses, but we do like to sometimes augment them and add some more. So what I'm showing you guys here is the last 2 weeks, and I will play it here so you can see, because really this eruption has lasted about 3 weeks. The first week was really more vigorous. The whole lava lake was open, and really the last 2 weeks have been more similar. So it's really, I'm interested more in the last 2 weeks rather than how it started. Maybe we've moved past that first chapter into the second chapter now. And so at a glance, these are daytime images only, because this camera at night really gets washed out with that brightness. And so I'll have it on a loop here, and we're sped up quite a bit, but that allows me to zoom in. So you can show you guys the active vent is up here, and the lava movement is coming around this way. There's channel that spills over kind of in this area there and that way as well, something like that, right? That's the pattern of dispersal there. So that's where most of the movement you see is, you know, between all the fuming that's going on. You really don't see a whole lot of widespread movement of the crust there. If I scroll over here, really not a whole lot happening in this central section right here. Right? Not a whole lot going on there. But if we scroll over here to this far right corner of this image, this is that area that we're interested in, where this is that low bench right here, that low ramp right there. And here is that lowest spot, somewhere right in here. So you see here that if we can just focus on that, there's a little rock right in here. And it's starting to get surrounded, right? So showing that this is getting a little bit flat, where you can have a lobe of lava coming out on this side, coming around, as well as a lobe on this side coming around to meet it. So it's getting a little bit flattish in there. And, you know, that would suggest that we're getting pretty close to that overflow point, right? And that might just be doing that kind of flat, showing more topography, making small little isolated areas like that. So that's what we have to look at right there. There it is. Closest we've seen of sign of overflow, just coming up over that edge, over the lip right over here. Okay, so that's the view from the B1 camera over the last 2 weeks, sped up immensely so that we can really see that movement coming up and toward that ledge very, very slowly. USGS is reporting a lava lake rising about 1 meter every 2 days now, as opposed to 1 meter every day before. And that's expected because the crater is flaring out, so there's more area, and it still seems to be coming in at a pretty good rate there. But here's a graph showing the lava lake depth in that area near the west vent. And we know that the lava lake is not level across its surface. And we'll look into that a little bit more. There have been times where that west end has been as much as, I want to say, 39 feet, so an order of 12, 13 meters higher than the eastern side. But it seems to have jumped up from time to time, so that more recently it's in a range of, let's see here, difference to the east, in the range of 7 meters or 20 feet or so higher in the west than in the east. So it really has varied a bit, and maybe that gives you some idea that different parts of the crust are rising at slightly different rates, as we saw in the past as well. Right, the previous eruption from December to May of last year to early this year. So bottom line, the lava lake is still rising. You can see the trend is still upwards fairly slowly. Interesting little variations here. We started to see those in the last eruption as well, but I'm not sure if this is related to some kind of degassing or exactly what, but interesting to note that there's some little cyclic fluctuations on there visible, superimposed on that other signal that's steady rising there. So over the last week, it's pretty, you can see really it's, if anything, it's sped up a little bit since this time between a 15th on a 15th, maybe halfway through the day or so. Okay, so that's the depth it's showing us. Which means, here going back to the B1 camera over the last 24 hours here, so it's just the last 24 hours, you can see, you can note there's some movement happening, some swelling going on. You see a little bit of red, not so much here, but you can see it on the edges there. So really, even though it's all dark and solid on a crust, we can see that this whole thing is visibly rising. If I pop it over to the middle here, it's hard to tell exactly where the seam in this video is, but if you watch some of these islands, it looks like they jerk up and down a little bit. This is just over 24 hours. So if the 24-hour animation is showing this, you can see that crust is really got to be rising noticeably, being pushed from below. And so still filling way below there. And we'll see some evidence of the lava circulating back beneath the crust in one of the videos USGS has released after our break here. So where is all this stuff on a map? Let's show you guys a map. This is the latest eruption map put out yesterday by the USGS. Reference map showing in this darkest red the active area of eruption. Let's see if I can get a different color here. Let's make mine yellow, right? So this area all through here, that's the active area eruption. The west vent is here and flowing out that southern path, and then there's like a northeast path right through there, right? And there's a perched area. So it's got this kind of perched pond with a channel, like a gully, a trench on the outside between this spot and the crater walls. And from this inner area, we'll see overflows out, especially in this northwest side, but other areas as well. You can see spillovers from that upper area into the lower parts of against the crater walls. The last caption that I noticed, USGS estimated the height of that is about 1 meter, 3 feet or so. So it's not super high, but it is there, and we'll see evidence of it changing as well. These yellower spots are the previous eruption products, right? So this is that central island that was a result of the high fountaining from the original north vent, December 2020 to December 26, 2020. This one over here was the west vent. It was active from the rest of 2020 eruption through May 2021. That was nearly this big before. Perhaps only the tip of it was exposed before, and then maybe that lower part, as the lava lake rose, was able to buoy upwards, and the whole thing expanded and essentially grew and sprawled, perhaps, right? And it seems like it is actually not as coherent as this island, which has stayed pretty intact, and we even have seen some fissuring across the edge of it there. This one seems to be deforming and almost flowing like a ductile putty kind of thing. So we'll look at that a little bit as well. These ones over here in the northeast are those former islets from that previous eruption as well. They're fairly stable and unchanging highs on that crusted over eastern surface, which is shown in this lighter pink right in there. That's the orientation of the actual lake itself. The viewpoints I've discussed. Kīlauea viewpoint is in an area of right in here. Perhaps, yeah, something actually maybe right in here. So you park at Devastation Trail if you can, and if not, you park at the Pu'upuai and walk that extra half mile there and along the old Crater Rim Drive to the path off the trail, and then get the viewpoint where you can see the fountain and the tip of this island. So you can see more or less this zone right in here, that perspective there. And that's kind of the view you get from Kīlauea Overlook. So the other viewpoints to the north at Waikahuna. And here is a former Jogger Museum parking lot. The main overlook is down here to the south, but if you go over to the east around this area, that's where you can have this view down through this trench, right through there, and you catch a bit of this edge of the lake right in there, something like that. And that's that view you get from Waikahuna area. So those are the viewpoints, kind of to tie it all together with the USGS map and the national park viewpoints there. And that's that, just the actual simplified map. We actually have a combination of satellite and thermal maps. So here's our most recent satellite image. Superimpose a thermal image with the blue being cooler, but still hot, crusted over lava lake, and that yellower and light blue areas being the active surface. And you see a little bit of red right by that west vent, maybe not so visible in this bigger image here. But first, before we move on to that more zoomed in version, I can just note the caption here of this compilation thermal image is showing the axes of the lava lake have not changed drastically since the previous overflight on October 8th. 1,020 meters, 0.6 miles east to west, right? So 1 kilometer or 0.6 miles east-west, and 725 meters or half mile north to south. Those are the dimensions, in case anyone is wondering, of that lava lake right there. The estimated area is about 55 hectares, 137 acres, and I should mention, I should go back to this map here. This map, besides having all this other geographic information, is also going to give us some statistics here. And updated through 1 p.m. yesterday is the most current data we have. The lake surface is 792 meters above sea level, almost 2,600 feet. That's underneath that west vent that's slightly higher. That makes the thickness 161 feet, 49 meters total during this eruption, right? That's not since the water boiled away. You got to add about 749 or 750 to that. That's a previous eruption, right? So altogether, you can see here that we're over that 900 foot, combining both of those eruptions together, right? And considering that even that flaring out cone factor that's going on. Lake volume is up to 6.1 billion gallons, 23.2 million cubic meters, right? So we're roughly halfway to what that last eruption did. The last eruption put out most of its volume in an early phase as well, and then took a long time to peter out. So that's one question we have is, we don't really know what the answer is going to be, but we'll consider what could actually be the pattern that this eruption follows. What might it do next is something everyone wants to know, and no one knows the answer to. But we can look at some of the factors involved in that too. But first, to wrap up the stats, active lake area, 41 acres, 17 hectares, and that's of a full extent of 147.59 hectares, 147 acres. Right, so big area. It's hard to fathom. You guys may remember the Empire State graphic that we showed last week. As a helpful visual aid there. All right, so thermal image. We're going to zoom into the thermal image here from October 15th, and you can see pretty much the same features that we've looked at before, but it shows how you can see the hotter areas. There's a zone of spillover from an upper perched area here. There's a zone of effusion right there, and it seems like there's even some over here. So it's interesting because these could be areas of topography where you have more exposure of the flow of lava, but there could also still be that original fissure that opened up, the central fissure, like something like that, and has output of lava underneath this crust, underneath all this lava, and we still have the question of whether it could also be contributing volume as well, right? It wouldn't be crazy to consider that. So there's that, and then the west vent itself is something we'll look at as well, thermally here. And so we're going to turn from this compiled thermal image from above and turn to the thermal camera, and start off here with the last 24 hours. Time lapse from the USGS of the F1 thermal camera. Our west vent is down here at the bottom. Let me get a good color to draw on. There's the west vent down there. In the last 24 hours, you don't see a whole lot of high fountains. You don't see a whole lot, you see a little bit of shifting of the ground, but we'll have to look at that in more detail at the longer time lapse to get more insight on that. You see most of the circulation near the vent with these occasional overflows, and this is that pattern of crustal foundering that we see, where you see these larger areas flashing more coherently. So likely there's less flow there. It's crusted over, but it's still overturning from the heat and flow into that below crust area. So not as active and may harden out eventually as the lava goes underneath that crust. Over here in the south, that's that area of heat that we're still curious whether there's outputs underneath. Hard to tell. Over here on the north, in this northeast pathway, it's more interesting to me. I'll show you guys why. We can zoom in right here to this pathway. We see a little bit of where this old west vent island is meeting this piece of emerged. I'm not sure what this is exactly here, but this is some spine of lava that's come out that doesn't seem to be either that previous north vent or the previous west vent, but something in between. And it's been moving also. And where these things meet has formed a levee, but this levee, the weak point is clearly right there. And so this thing is built up, and it seems to breach this point over and over and over and have overflows down into this area, which are visible from that public overlook. It's just, you have to know exactly where to look. You have to not look at the fountain as much, but a little bit more to the right. You can see these big, massive, huge sheets of pahoehoe, apparently looking lava, like coiled and with big surfaces, riding down and flowing and spreading across that back valley wall over here. So really, really cool stuff to see. Sometimes you see that over here as well, but more so down here in this lower section, right? And so what's really cool is you notice this dark spot right there. That block is actually moving here in the last 24 hours. And we'll show you guys, if we rewind it further, it actually comes from this gap, and you can see it actually has been riding, getting pushed out of the way to its current location over there. Right? That's that area. So we'll look at that in a little more detail at depth, but first we'll pull out the USGS photograph that you have of that exact area right there. There is that pinch point between those two areas where the lava is spilling out and over. You can see that drastic change in topography right there, where it's really clearly downhill, and we can see why it floods that area so much. And as all these other areas keep rising, this is all rising together as a whole, this whole unit, so that is somehow being maintained, right? It hasn't filled up all the way yet. It seems to be filling over here faster and still spilling over this area faster than it can fill. All right, so let's go back to the F1 camera here, and now I'm going to give you guys the last 2 weeks once again really fast. And since we were just looking at that little gap, let's focus on that little gap here first of all. Some cool stuff is happening there. First of all, you can notice how that this island over here is actually moving. We'll look at that here shortly. But you see the gap opens and closes, opens and closes. At the very end, you see that rock pop up and flow down this way over here, right there at the end, right? You also see some other things drifting, or some rocks drifting in here. Not quite clear where that comes from. But really fascinating. While we're in this sector, let's look over here. At this north edge in particular, right in there, you guys notice there's actually like a rift. There's a spreading center. Lava is coming up from below and pushing in both directions, left and right there, to the point where it's breaking off pieces of this harder material and making new little islets that are floating over towards the south, right into this little bay that's now north of that central island. That's really interesting and cool, and something that we don't see as often, and unexpected. I haven't seen any other mention of this yet. So this is kind of breaking for us to point us out, right? You can really kind of see how maybe there's like a pathway, something like that, where it's splitting open and everything's moving. This island's been moving to the south for a while, or to the bottom of our image, which is actually to the northwest. And really that spreading center visible right in there. And so that's a really, really cool aspect of that. If I go back to the last 24 hours, there's one other thing I wanted to point out here I forgot to mention. And right here off of this westernmost tip of the central island, you can actually see another one of these little bobber pieces of crust float up here. So I'm not quite sure if this one came from this nearby island or where exactly it came from, drifted down and popped up, but we're starting to see more of these little islets emerge as well, which is interesting. We saw that before. Okay, so that might be enough time on all the thermal analysis here, but that's some of the cool stuff we can see. You can see a little bit more of this pattern of how we actually had pulses of overflowing more so on this crusted over area, and really it's pulled back since then, right, and less flow, right? And considering the exit points of lava early on, or that fissure line right in here, you can see that towards the end we don't have that nearly as much. It's more of a single channel spilling over, so not quite clear what's happening underneath there, but certainly changing dynamics on the surface, changing fountain heights, and we'll look at the data coming up, just a couple of slides here as to why that might actually be. So looking at why the west vent is actually lifting up, and here maybe that's the last thing I should have pointed out, is looking at this west vent area right in here, you can see the whole thing is rising up, right? This is the whole last 2 weeks. And so notice that it's not the vent actually growing by lava dropping on it. The fountains are not necessarily coming over the edge the entire time, although there is a spurt there that they do. You see this whole ridge over here rising as well. You see this piece rising as well. You see this side over here rising as well. If I zoom it out, you see this whole southern ridge, the whole thing is rising all together, right? Even as we see the spreading out of the middle up here, we see all this rising all together. This whole back half is rising all together as well. Even as lava floods over it, the whole crusted over section is floating, rising upwards there. So when we talked about this height of the fountains, height of the vent, here is this complicating factor right here. If the whole base level is actually rising with the cone, and the cone is reshaping itself at the same time, growing, collapsing, but the bottom of it's actually rising, you can imagine how that complicates the measurements, any issues there, and why we can have some ambiguity and some changing numbers, right? So that is my my take on that range of numbers that we're seeing there. So that's really interesting because it shows that this whole vent is being lifted up together. Unlike what we saw during the last eruption, the north vent itself got all the way drowned. The whole cinder itself got drowned until only the tip stuck up, and then it started floating upwards. That was true with the west vent as well. It didn't really flow upwards as much until the end of that eruption, or maybe at the beginning of this one. And this one doesn't seem to be attached to the wall at all. It seems to be actually floating up on that crust that's rising. So that's really interesting, a little bit different. And if that's the case, then we can't judge the height of the fountains compared to the wall of the vent as the absolute height of the fountains compared to before. So it could be that lava is feeding more underneath the crust of the lake rather than fountaining out through the hole. There's still quite a lot coming out through the hole, which makes it even more impressive that it's still sustaining fountains of 5 meters, even as it's rising and the whole base level is rising up. So then you know that the fountain is coming up through the lake, underneath that area, and then up to that cone area, right? And so essentially we've come to the point where the lava level is above where the vent originally was, and it's still sustaining eruption through the lava lake. And that's something we did not see as much in the previous eruption, 2020 to early 2021. And so does that mean that because it's got more of this oomph that it'll burn itself out quicker? That's one take on it. The other take would be that's something we see in eruption patterns, is that the higher the output rate for longer, then usually do last less time. Or is it some sign that there's enough pressure underground in a magma reservoir that this can sustain for a longer time? We might have perhaps more months of it. Yeah, I don't know the answer, but those are the two considerations that you might come up with. All right, so okay. Now, as we consider why that whole area, the west vent, is rising, it's useful to look back at this photograph of that early opening of that west vent fissure, right? So then the current cone is built around this area right in here. And we've seen bubbling sources from the side that we thought might be over here, but you see there's also lava output there and over here. And so we only have a cone above this area where it's fountaining through the lake most vigorously, but you might have outputs on the sides elsewhere as well. And focusing just on this area rather than going over to the center, we'll look at this USGS video here. Right, so this video is from October 12th, and they're saying that the fountaining was 10 to 15 meters, 30 to 50 feet above the lake surface, with larger bursts exceeding the height of the cone, which at this point was being referenced as 30 meters, 100 feet tall. There's a smaller vent to the north with fountaining 3 meters, 10 feet, spatter reaching 10 to 15 meters, 30 to 50 feet right there. So I'll play it for you guys, and you'll see we're looking at the same perspective more or less as what we just saw from the previous view with that fissure line. And any second now. Oh, there's some wind. Let's cut out the wind. All right, there is that second vent over here. It's just outside of the cone. It's showing indications of that original fissure line right there. So you see that vigorous fountaining through the lake, and actually through the lake outside of that cone, and that is something that maybe is less surprising now we see the whole thing rising up together. Let me rewind it a little bit so it can play one more time. You can see that area over here off to the side spattering up. And we've shown photographs of this before, but the video came out since our last update, so I want to make sure to include that. Really fantastic spattering. You see that's how the cone gets built. Layers of lava just coat and essentially put another layer of plaster over and over and over until you have that whole surface there. Okay, so that is the visual of that rising lake, and so now we'll turn to a quick data run through, and we'll look at the USGS update as our guiding and source for all of this. So I just want to make sure we shot them out one more time. And we're still at watch orange level. There's not a whole lot of changes as far as a report here. Noteworthy things. SO2 rates are down substantially. They're at still 2,700 tons per day. It's still a lot. It's a lot more than a non-erupting volcano, but it's a lot less than that we originally came out with. So it's really been petering off more so. Maybe last week we might have been around 5,000. So we're still having measurements that it might be in the several thousands above this 3,000-ish value. But they're also dipping down into that range more frequently now as well. We'll keep going here. Here's those same measurements. I gave you guys measurements from October 20th, so I won't go through all this again since we have more current stuff from the map. But we can see here that fountain heights consistent of 5 meters, 16 feet, occasional burst 10 meters, 33 feet was a report from today. They're now saying, as of today, 8 meters, 26 feet difference between an active west and stagnant east part of the lake there. As far as the East Rift Zone, they're saying that refilling of magma since late August 2021 has slowed or decreased slightly. That's a slight clarification. So there has been refilling of magma of the East Rift Zone, but it has slowed or decreased slightly, and perhaps even more so just in this latest weeks here. We'll get into that here as well. Hazard is still mostly the gas and particulates coming out, and we've discussed that before, so we'll come back to that again here at the end of this data segment. But having touched on that, the numbers, we'll show you guys a tilt. This is the last month. Build up to the eruption here. Eruption begins. Long deflation, like an exhale of the volcano. We had that big 6.2 that shook it. And before that actually happened, it looks like it's at the same time during this in this month-long plot, but we actually noted at the time, a few hours before that actually happened, the volcano seemed to have flatlined with little variations, but it's been mostly flat with perhaps a slight decrease and maybe less decrease, but it's been fairly unchanged since about the 10th or so, compared to the previous week and a half before that. Looking at the gas data, you see a similar kind of pattern, right? It peaked early on at 85,000 tons per day the first day of the eruption, down to 20,000 tons per day a few days later, down to the 10,000s, down to the 5,000s, and now here we are in a very few thousands most recently. So looking just at the gas as a proxy of how much lava is coming out, we can see that it seems like that gas is not getting released as much. Worth pointing out that in the past we've considered whether the lava vent being drowned might absorb more of the gas in the lake and release it more slowly. That's a consideration that we have not heard anything about from USGS, but it's something interesting to think about as well, whether that might affect that output of gas. As far as ambient concentrations, we won't look at the exact details. You can see the overall pattern has been higher values early on and decreasing peaks, right? So higher and more frequent peaks in that first 10 days or so, 11 days, and then less so since then. and that's a general pattern across the board. Of course, variations from wind and all of that, so that's all expected here. Okay, I've been talking for a while, so let's wrap up the data. As far as tilt, you don't see a whole lot in other stations. It seems like that flatlining is visible also at Sand Hill and at Kīlauea. You might even see a slight increase appearing right there, right? So clear change, turn around if it's slightly increasing. We'll call a slight increase the same as this flatlining within this margin of error, and definitely not the same as what we saw before with this longer deflationary trend. That's what we see in the summit area. We really only have those few to go by. Going further to the rift zone, Pu'o is deflating very slowly and nothing happening lower down lower east rift. There's no sign of anything going down, and so far Eruption is showing no signs of moving from the summit, right, as expected, and no sign of that changing. Although, rift zone is rift zone, it's a matter of time someday, but no sign of it happening anytime soon. More deformation. We looked at the zoomed in month. Here's the last day. Our scale is only 1.5 microradians, so these little variations might look like a big thing, but these actually is just a fairly small variations. Look at the last week. It's a little more dramatic looking right here, but you can see more of these variations up and down, fairly small magnitude that zoomed out would fall into that area right in there. Okay, so not a lot to see from the tilt apart from short-term adjustments. The GPS is a little bit different than we saw last week, right? The GPS takes a little longer to come in and collect data, so we now have a full week of having seen it appear to have flattened out, and now we can actually see, okay, it clearly did change at that time we thought that might be last week. And rather than having a contraction across the summit caldera, north to south, we're now having an extension again within the last week. So clear and obvious change right there. Caldera now spreading apart as if the magma is not able to release its full pressure through the eruption anymore. It's erupting while still now resuming building up pressure underneath the summit of the volcano. That's the major change that deformation data is telling us here. That's not as visible on a rift zone. The rift zone is showing a trend that's actually opposite of that. There's one stray point here, but the overall pattern has not changed. The rift zone has actually been a contraction of the rift zone and then perhaps more contraction of the rift zone. And that might be the slowing reference by the USGS might refer to this more recent pattern right in there. Okay, so in more detail, the GPS at Waikahuna, we can see around the summit regions. This is essentially the intrusion. So you can see magma is moving within the volcano, adjusting quickly, and then building back up pressure, and then moving quickly and building back pressure. So we can see the change happens at Waikahuna. It's changed trend there. In the east-west, the north-south, and in the up-down. Byron's Ledge, a little to the east, is a little bit slower. It's the slowest station to respond. It looks like it's a little bit, or we saw last week. We haven't quite seen a change yet, but it seems to be slowing down. So that station is interesting that it's lagging a little bit in the eastern caldera area. We'll touch on that as a connection possibly to Kilauea tilt we just saw. There's maybe some slight inflation there. Maybe there's some adjustment of magma underground within the summit reservoir area that's shifting a little bit more to the east, where you might see some funky stuff in the Kilauea Byron Ledge area. So that's localized, and I'm not sure it's meaningful as far as anything further happening there, but noting that seems to be an area of interesting signals right now. Further on, Crater Rim in the south, you see the pattern change. Essentially, everything has changed back to its pre-eruption trend, pre-intrusion trends as well, right? So it's a similar spreading pattern. While elsewhere in the rift zone, what we see is not a change, really. We see since eruption, continued contraction, no more rising, no more moving north, no more moving east. It seems like the rift zone is actually still sagging, which brings up the possibility that you might have some restricted flow, or possibly backflow. Maybe the magma is flowing, that you have a net loss of the rift zone, a net gain of the summit. Is it because there's some flow from one to the other? Is it because there's like a blockage that is constricting it as the magma is adjusting, is maybe pinching some points closed and others open? All that's part of the adjustment of the volcano underground, and that happens all the time. A lot of times without eruption, but it could lead to other eruptions interesting in a summit east rift connector area. Who knows? We'll have to wait and see what the next chapter of the eruption actually brings. But noteworthy that you see those trends. On the rift zone, you see it all the way to Pu'o at Jacuzzi, whereas further over past that, in the lower east rift at Jonica, you still see a whole bunch of nothing changing. So really no connection or effect obvious right there, right? There's clearly connections at deeper levels, but nothing that seems to be moving very, very easily, the pressure through there. So we'll stop the GPS deep dive right there and finish off with earthquakes and gas. Here's the earthquakes over the last week. Not a whole lot around the summit. It's been pretty quiet. South flank is still continues to be active at a low level, as it has, regardless of anything else happening in the volcano, as it does it all the time, it seems like. Interesting to note here, there's a couple of deeper events than usual in this East Caldera area as well, or the Kilauea Iki Byron's Ledge area. So that doesn't mean anything apart from adjustments are happening in perhaps less than usual ways over there. Right? But nothing to be alarmed about in that area. There's no rapid rise, no big earthquakes, anything like that. So just a couple of small interesting ones. Here's the numbers, earthquakes per day. You can see that our intrusion peaked at 160 earthquakes per day, and we've been in this level of around less than 40 for a while, ever since our eruption began, right in here, right? So that's sorry, our intrusion was here. Our pre-eruption buildup was right in here. Or actually, no, this is our whole pre-eruption buildup. I'm sorry, and our intrusion is actually scrolled off the map back over here. So that's what I am meaning to say there. Okay, so as far as current seismicity, there is a map of the island. There's still some events happening offshore. 2.7, 2.4 with adjustment earthquakes. We have some ongoing aftershocks to that 6.1 we had a week and a half ago or so down here west of Loihi. And you still have quite a lot of this pahala action going on, right? A lot of earthquakes still active. The area has been more active than usual still. It's very, very deep and not connected to the surface in any obvious way. We have heard reports of tremor in the area. Dan, you want to jump in here and tell us what you investigated about the tremor?
Yeah, that was interesting. It ended up being seen across all the stations on Mauna Loa. Pretty clear signal. Last an hour, half hour, somewhere in there. And it was clearly a tremor, and you could even pick it up on the north side of Mauna Loa, or Mauna Kea, north side of Mauna Kea, and you could even see it going down the rift zone of Kilauea. The interesting thing was I was discussing it with a seismologist, and the thing about that we were noticing was that the further away from the Pahala deep earthquake area and the tremors there, the weaker the signal seems to get. And that wasn't true on all stations. There were some stations that just didn't show it. But in general, that seemed to be it. And that was kind of the thoughts, was it was the deep Pahala tremors somehow being able to be felt, across the large part of the island.
Yeah,
Still haven't heard anything more on that yet, but it is interesting.
Yeah, it makes sense to me. If the earthquake's actually 30 miles down, right, it's the same distance as it is from Kilauea summit to Hilo, more or less, or to the east of the island, Kapoho, right? Imagine that distance sideways being up and down, and then suddenly you can point to Mauna Kea, to Mauna Loa, to Kilauea. It's about all the same distance everywhere. It's not actually like it's closer to Pahala just because it's right underneath it. It's just, that just happens to be the angle of it, right? So interesting to think about there, and thanks for digging that out and talking to Dr. Shiro about that.
Yeah, definitely. It was interesting, and thank Jennifer for pointing it out as well. It's always, interesting things down at Pahala, basically, when you start watching the seismographs down there. And Jennifer asked, can we show the Waialai seismograph?
Yeah, here it is up on the screen, and you can see, let's look at it a little more. This is peaking from 1700 to 2200. Which I thought was a little different. Let's look at the time on the other one here. So let's see oh, no, we can't go to the saddle one. Let's go to the north of Mauna Kea station. Look at that band. That band is coming through between 10:45 and noon on the 20th, yeah.
Yeah.
So if we go
that's what I'm showing.
10:45 to noon on the Waialai station, is actually stuff right in here. So there's something else going on in the evening there that's more localized, and I'm not sure if that's like a wind or construction or traffic. I don't know. You'd have to. I'm not sure if that's even possible where the station is located right there. But that would be what to consider, right? So let's look at this one over here. See if we see that same signal. Oh no, we have some missing data, so it's not going to show us. Look down here. That station, nope. Missing data once again. This sometimes can get frustrating. Let's look over here. Missing data. All right, we'll try one or two more. Okay, there's one. So it shows that initial tremor right there, and then it's showing some other stuff going on in that same segment. So maybe there's some adjustment happening. If it's localized right in here, but it could also be maybe some wind coming through this quarter. I'm not sure exactly what's going on there. Localized, yeah. And if we look at the rest of Mauna Loa, let's look at Mauna Loa up here. Then you see that signal is not on the rest of Mauna Loa, right? It's not a Mauna Loa summit, so not Mauna Loa magma chamber or anything like that. It's something else, whereas there is that Pahala signal right there. So that can be our deep dive in the tremor.
Yeah, Jennifer's saying that Hualai one, USGS is saying wind and rain.
Wind and rain, yeah.
For that one.
Oh, mahalo. All right, so yeah, moving on from the tremor. Tremor is something people are feeling earthquakes and stillness in this region more often than we give credit for it. They're still happening, but it's still going on there. Yeah. All right, as far as air quality, let's see. I'll probably have to reload this because it doesn't like to be brought out from a tab. But as far as the DOH, State of Hawaii air quality, we're greens across the board. But remember, this is a combination of SO2 and particulate matter, and so we like to, for example, go to Pahala and screen here. We've been in a green, even at elevated levels, and that we're not zero. There's still gas moving on there. We were in a yellow a little bit yesterday, but we haven't seen any of that red and purple coming out, right? So gas emissions are down. It can still concentrate in certain areas, especially with stronger winds, and drift around and get caught in the Kona side especially. So that's where this DOH data doesn't give a full picture, and we like to add in here purple air, and purple air is showing more particulate concentrations here on this Kona coast. So maybe a little bit haziness still in the air, but should be reducing overall in the long term here. But there it is there, documented for all to see. So as far as the forecast, not surprising to see the wind direction coming around and wrapping around. That's a typical pattern. And so you really have Pahala, Ocean View, and South Kona as our typical areas exposed to the VOG and particulates they're forming there. VOG being a combination of SO2 and particulates, right? That's how I should say it there. For viewing in a national park, to kind of wrap up our segment here on data, we can go up to everything is green. And to summarize it, here is a park map. Everywhere you look in the park is in the green. It's all upwind. You can see here, this is the direction the gas blows off that way, and all the viewing areas are on the upwind side usually. And even when it's fairly low winds, like it has been a couple of days ago, you have a thing going more up than you have it going towards this low area over here. So the air is still good. So with that, Dane, we can wrap up our data segment here and move on to some thank yous, some questions. I will pass it to you.
All right, sounds good. So yeah, definitely we want to thank everybody that managed to come today and is here in this chat, watching these streams. Best way to help out is to like, subscribe, consider sharing it on your social media. That really does help us out tremendously. We also have a couple sponsors that we want to give some shout outs to because they definitely help us out. If you want to make a monetary donation or you'd be interested in advertising yourself through Hawaii Tracker, check us out on hawaiitracker.com. And to support us directly, it's hawaiitracker.com/support. We do have a couple sponsors want to shout out. The first is Kilauea's Bar and Grill in the heart of Pahoa. And they're also going to be opening up a second location in Orchid Land, I believe, this week. They do a bunch of different twists on some traditional dishes, add a little bit of local flair to them, indoor, outdoor dining, all that kind of stuff. Plus, they are hiring right now for the new location as well. Everything from cooks to hostesses. The if you got a resume you want to drop off, you can drop it at Kīlauea's and they'll try and get you in. Second one is Kalani Tours out of Kona, and I bet they're busy nowadays with the volcano tours, going up to the summit and taking people around, talking about some of the history and some of the little stories that really bring the summit to life. And they also do some waterfall tours and Kona coffee farm tours. So yeah, check out Kalani Tours in Kona as well. We are also supported by the Hawaii Community Foundation through the Puna Strong Grant, and we want to thank them and the County of Hawaii for their support as well. All right, I think we're in a question time, huh?
Yeah.
All right, so I got a few here. Let's see. The first one was from Richard, and he was asking about the temperature of the magma being erupted. And the question is about the temperature fluctuating. Do you think it has been fluctuating or it does? And I think that's an interesting question, since we do know the 2018 eruption definitely got hotter as it progressed, right? So what do you think?
Yeah, we haven't heard any of that data. And so the first question, it comes out in a range of temperatures that's actually fairly narrow, right? So I ballpark it as 1200 Celsius, 2200 Fahrenheit, but it may actually be in a range of 1180 to 1140, something like that, right? So you might have like tens of degrees separating these different lavas, but that's something measurable in the chemistry of the crystals that erupted. And so the geologist will collect rock samples and analyze the crystals within them and get some history of the cooling rate of those crystals and temperature at which they cooled. And that tells you where they come from and whether it's more volume of fresh magma or whether it's mixed with some older, colder lava, which is how you get different temperatures of lava, is by mixing hotter, fresher stuff with older, colder stuff, right? Certainly you could have colder stuff in there, but considering it's only been since May since we last erupted and stuff was flowing out, it can't be that cold. I mean, probably the coldest thing you had to start with was the lava in the pit itself when eruption began was a giant heat sink compared to the lava that was coming in. It was much hotter than it. But I think we're past that now, where seems like it's all coherently mixed and all rising together as a more homogeneous thing, right? Yeah, I mean, it's a good question. That's more or less the ballpark of temperatures. That's more or less the range of it, and why it's hard to really, you can't visually be like, oh, look, clearly it's hotter and clearly not as hot. You just can't tell with your eye. You have to really wait for the chemistry to come back. And it wouldn't be surprising to see that pattern, as you say, Dane, right? But that would be important, because that might give a hint at whether this change in inflation is due to this surge of hot stuff from below, or whether it's just a vent drowning, for example. That could be something that might give you some more of a hint at that.
All right. Casey asks a somewhat related question. Is the solidified material, the solidified lava, less dense than the lava in its molten state, that it would float up on its consistency? I think this is kind of going back to that iceberg idea that we were talking about as well, for the iceberg floating on the water. Pushing the cap up.
Yeah, I mean, it's really interesting. So it's all a matter of buoyancy, right? And the thing that affects buoyancy the most with lava is the amount of gas that's trapped in it, because really, any variation you have of the chemistry of the lava itself is minor compared to how much gas is in it. Just changes it by orders of magnitude. So when eruptions begin and are gassy at the start, they form kind of frothier rock, and that rock naturally has more void space, and it would be more buoyant and float. And that's why we think that those islands are formed largely of that spatter material that's erupted in this higher fountaining. They're not high fountains, technically speaking. They're not that high, but they're the highest of each eruption, right at the beginning phases of them. So in that sense, yes. And piggybacking on what we just talked about, if the lava that's in that pit has had a chance to cool and degas a little bit, then compared to the fresh lava that floated out before and formed that crust before, it's actually has less gas in it, and so it might be less buoyant. And it might be that you have to come to some point where you mix enough fresh stuff into it to get the whole mass of it buoyant enough to actually overcome the buoyancy of those islands. And maybe if you get enough lava in there, it'll happen at some point eventually. But so far, we haven't reached that, right? It seems like we have more colder degas stuff, perhaps, is one possibility, than the hotter, fresher stuff coming in, right? We looked at the numbers, 41 million cubic meters in the last eruption compared to about 23 so far in this one. So 2-to-1 ratio of older stuff to newer stuff, right? So overall, possibly colder slightly and degassed slightly to the point where that younger stuff is still able to be buoyant and float on top. That's just theorizing of what might be the case with the factors that have to be involved.
Yeah, definitely interesting. A lot more dynamics than that. The last eruption, with the eruption on top of the eruption now.
Yeah.
We have a $50 super chat from our friend Gary Bryan. And says, appreciate these updates, detailed and thorough 360 review. Thanks, guys. Thank you for the continued support, Gary.
Mahalo, Gary.
All right. Victoria asks about the fissures underneath the crusted lava lake. Are those still active and just not visible, or are those inactive now, in your opinion?
I think what we talked about is, and showed you guys as far as a west vent being active and that side vent outside the cone, and that leads credence to the fact that at least that one is erupting underneath the lake, yeah. And so if that one's going, I don't see why you can't have that southern one going. The southern one was the initial one and seemed pretty vigorous as well, right? And then somehow we have not exactly a fissure, but some upwelling that's splitting that northwest rim thing. That I don't even know what to call that. That's really fascinating. That seems to be a upwelling area. It's not an actual fissure there, so it must be the lake just convecting and turning over. And that's interesting that it's starting to do stuff like pull up this more spiny, harder material, and it's just rising out of somewhere in the depths down there, and it's actually able to flow and break apart like fluidly, right? Like a silly putty, rather than actually breaking and cracking. So that's really fascinating, unlike the other islands so far. It's really interesting, weird stuff going on in there.
Yeah, we had a question about that as well. I think that kind of answered that one. Shannon asks, is it possible for this eruption to fill in that down-drop block in this single event, or I guess coupled event? We couple it with the last eruption.
Yeah, so I mean, certainly it's possible. The trend of the last eruption was that it peaked early and it kind of tailed off after that. And that's how most of them go. It seems like they don't peak and then go down and peak and go down at the summit recently, right? We have had that kind of pattern at high fountain of Pu'o'o, Mana'ulu, those kind of things. But we're not seeing that kind of pattern now. So.
Yeah, there was one more question about from Mad Hacker about it possibly turning into or building up into high fountains from here.
If there's enough pressure down there, right? I mean, the fact that the lake is drowning the vents, that makes it seems to be less likely. But if the result of the inflation is not the vent drowning, but rather magma coming from below, then you could have that kind of thing happen, right? Renewed surge of gas and that kind of thing. And if that were the case, then you're much more likely to fill that thing in shorter term, right before the eruption ends. Otherwise, it's just a lot more volume. It's just a huge area. And it seems more likely than not that it's not going to fill it up in this eruption, even if it lasts months and months and months, because it's such a huge area. The current rate it would probably take, I haven't calculated that, but I'd estimate, years based on what we calculated in the last eruption last year. Something like that, yeah. So probably not possible, and it would require some large increase in output.
All right, well, that'll do it for this first segment of Q&A. We will be doing one more. If you have questions, go ahead and throw them in the chat. We'll try and get them together for the next batch. All right, back to you, Phil.
Yeah, mahalo, Dan. And just to reiterate, this volcano right now is all erupting within the national park, away from any houses and people, and there's no threat to anyone. It's just a perfect viewing situation where everyone can see it, and it's not actually going towards a lower east rift zone, which is a few people have.
I do have a PSA. Though.
Yes.
The national park has put out a press release about speeding and inside the national park, and I think 3 nenes have been killed in the past week up there. And yeah, just take some care. The birds they kind of they have a mind of their own. Sometimes you got to be mindful of the nene, be careful with them, and yeah, keep the speed down in the national park is what they're trying to ask people to do. At the Ben Hayes has something up on Hawaii Tracker right now, so yeah, just wanted to reiterate that.
Awesome. We definitely need to hear that. Mahalo Dane. All right, so all right, we're gonna turn to our final segment here. We're gonna do it's gonna be more of this show and tell, pictures and video. Start off with some of the USGS video, and then we'll transition to talk about the Volcano Watch and this mega-tsunami landslide topic that we won't spend too long on, but we'll talk about it a little bit here at the end. So starting off, let's get this USGS video going here, and we'll start off with let's fast forward a little bit here. A different view of that side vent down here. The main fountain, reverse angle, you see it's kind of coming out at the back side of the fountain through the lava lake itself in the back there. And so worth seeing that. And then the actual main vent itself with that exit point and some fantastic spattering, and you see the spatter landing, and it's hard to imagine, the size of these clumps of lava, really, right? We heard at one point in time that this exit point right here was about 10 meters, 30 feet across. It gives you some perspective of the size of these globs that are shooting out. And yeah, this is now a point where the lava is going back and circulating back in, and as it comes back in, you often see this, which we've been referred to in the past, grotto-like feature. Let's put it back to the grotto here, where the gas is bubbling out at this downwelling point as the lava goes down. The gas doesn't want to do that, so it kind of comes up in this area and against the edge of the pond. So this is some sign of circulation happening within the lava lake, which is interesting. And another view of the pattern of the crust forming and deforming as the lava that's already beginning to crest over shortly after it comes out of the vent within seconds flows into that lava lake, and you can see that really amazing geometry there. So that's one video from the USGS, going to connect us back to what we saw before. We'll load here. This is another view into that west vent, showing heights of 30 to 50 feet, 10 to 15 meter fountains with larger bursts there. So a different angle, different perspective of this USGS provided fountaining videos here. So really great to have these perspectives in addition to what you can see from Overlook. You see what they can see from the closed areas where they're monitoring a volcano as well. So that's how it looks from that side over here. And let's turn now to the USGS overflight, October 15th here, shown at 2x speed. So different perspective of the crater from a few different angles here. And you see in the daytime, mostly see that silvery crust, the west vents over here, top right of the image. And still quite a bit of gas coming out the perimeter. You see the lens rainbow effect here coming across as the helicopter rotates around the crater. You see the west vent, you see some spots of red at the edges of that perched area there, but there's that lower southeast point where it might actually start lapping onto that mid-level down drop block. It extends all through here. That's the first clip. Here's a little bit more low angle. You can see when they got those low angle views looking into the mouth of the vent. They were doing it from this perspective, low and across the lava lake there. And you can watch this here. This is that ledge that has a piece of road on it up there and over here to the side as well. And down here is where it might start lapping up and spilling over once again. Great view here, and that's the overflight from October 15th. And I believe those are the main videos, and so we'll start covering some of these images here. And I won't go into detail on all of them. I'm just going to make sure we show them as being here. And so here, another view in the daytime. Mauna Loa in the background, the vent here. Lots of these daytime views, reverse angles of the vent. Talked about this in a lot of detail already, so I won't have to beat a dead horse. Right, different nice view of the vent from above here from the overflight. You can see that gap and the shape of it. A horse, like a horseshoe that's closed in here, right? Closed in at the bottom. So not quite a full circle with a little gap where it feeds into the lava lake. Blowing up perspective there. And once again, the one we showed you guys earlier. And a view of the HVO geologists in the helicopter photographing out the window there. And that's what they're doing to provide us with these fantastic images some of the time. Sometimes from the ground, but the overflights usually once a week. Interesting to see that as well. Different perspective here from you're kind of walking all around the crater from different areas. So there's a different perspective of that. You can't quite see the exit point, but you see that backside of the cone a lot more. It's not as obvious if that smaller vent on the side here is still going in these photographs. It seems like it was more obvious coming through the surface of the lake, but it could easily be there underneath that surface as the whole surface has risen up as well. So that's ambiguous what's going on there. And on the 15th, we have those couple of videos we showed you guys earlier. So we'll move on to the photo release from the 18th. Another view of that west vent perspective here. We've seen a lot of that, a pattern coming through. A rapids area, plunge point, reverse angle. Often seeing this spatter landing on a cone itself, growing the cone over time. And our video here from the 18th as well. All right, moving to the 19th. One more time. Cone. Fountaining with the caption of the height we discussed before. 25 meters, 80 feet high. Reverse angle once again. And more of a wide view in the daytime here, right? So showing all those areas we pointed out on a thermal image. Various islands, breach points, pathways as they look in the daytime as well. The aerial video was posted there, and the maps. And that wraps up the 19th release. And so there's one more day of release was yesterday. And you can see similar patterns. You see fountains still within that cone. Wide angle view looks very similar. There is that narrow exit point that we zoomed in earlier when looking at thermal. And here is the map, reference map that has all the most recent statistics of the eruption. A little bonus here, a little bit more from the 19th. Small fountains, you can see in this particular view, right there is where we actually have a little bit of a crusting over of that pathway, right? But I can tell you that by this morning that's no longer there. This is probably some temporary damming, and it was going underneath here and popping out the bottom, but then since then, this thing has broken through and popped out of there, opened it back up again. Which is interesting, right? So this whole perch level on the inside seems to be rising with this whole cone and the crust underneath it as well. So this rapids is been preserved through the couple weeks here, actually, which is interesting. All right, that the central island is actually showing lava circulation on its south and its north here, so there's the perspective of that as well. That former fissure on its east side seems to now be inactive, although still venting quite a lot of gas, and maybe it is coming up underneath the crust there. We just can't tell. We do know that the whole eastern half of the crust is rising still, as we said before. So whether that's just from lava coming this way and going underneath the crust, or whether it's coming up from below, still ambiguous there. And a couple other perspectives here, and the USGS photo release here with a view of the full moon rising through the gas plume here. It's glowing orange in the evening. And so that's that first part, the USGS releases, and we'll make sure to touch base back here in our S1 camera. Last 24 hours time lapse, that's what's going on now most recently. So you still see that rapids plunge point area right here. Still see fountains coming up in that west vent. You still see that circulation to the south. You can't quite see the spillover point behind this ledge right over here. But you can see the northern flow going this way over here, when it seems like it must dive down somewhere under the crest in this area. And it also breaches through that little gap overflows out through there, as we described before. And I can refresh this, and since the sun is already setting here in Hawaii, you can get a nice current glowy view what's happening down there at present. Okay, it's nice to check all the webcams at this point of the day. So there's that S1 camera, B1 camera, KW camera. There's nothing obvious in any of these. It looks like our KO camera has not been updating since the 15th, so we'll have to move on past that one. But you see the wide angle views here. Fairly clear sky. The fog is really blowing off to the side over that way. The most recent thermal view right over here, you can see really one visible entry point and one visible plunge pool. That's the most obvious, and it's still, you really don't see anything happening under the surface anywhere over here or really, even over here. But you can see that in the long term, those are fluctuations that do occur. All right, there's a lot more pictures of the eruption going on. This is a great time to visit the volcano. The volcano has been putting on a show for all the tourists and visitors to Hawaiʻi Volcanoes National Park, as well as the locals, right? And I'll see a lot of locals day after day after day in there. So to remind you guys, you can go on hawaiitracker.com, on Hawaii Tracker Facebook as well, and you can get some of these other images over here, right? There's the Nene posted by Ben Hayes. We're sad about that as well. It's terrible to see these endangered geese here that are a Hawaiian state bird being impacted by the tourism here. That's not how it should be going. So, all right, see if there's us, there's moon views from the overlook, other attractions of the island and interesting things as well, right? Island views, imagery, see all kinds of good stuff here, including a lot of volcano stuff as well. So check that out. Short videos. Just a little preview there, what you might find. And so we'll shift away from the photographs now and touch on some of the USGS news releases. There was earlier today at 10:21 a.m. Hawaiian time, the Great Hawaii Shakeout Earthquake Drill. So wherever you were, if you were practicing in part of the group routine, you would have dropped onto your hands and knees, covered your head and neck with one arm and hand, caught underneath a table or desk that was sturdy, or next to an interior wall away from windows, and then hold on until the shaking stops. And that was the drill at 10:21 this morning. Don't have anything really. Can't show you guys the video of me doing it or anything. That didn't tape myself or anything like that. But.
Right. I'll just dive under the desk now there.
Yeah, only 8 hours too late.
Yeah, well, it's
10
o'clock somewhere.
As long as you practice, that's all that matters, right? So yeah, we'll give it anyone else who gives it practice, race it, go.
Right.
All right, so all right, we'll switch to the Volcano Watch. Volcano Watch this week, the Canary Islands mega-tsunami hypothesis and why it doesn't carry water. So they're giving away their conclusion right here to start. They don't think it carries water, but they'll go through this a little bit. The recent eruption on La Palma, Canary Islands, has stimulated speculation that the volcano might collapse, creating a tsunami that would devastate the east coast of North and South America. But is such a scenario possible or likely? And here's an image of that eruption in La Palma. Lava coming down, ocean entry, forming a little lava delta there. So there are similarities between Canaries, La Palma, and Hawaiian-style eruptions. Both have potential for flank collapse. Both are basaltic ocean islands, and there are catastrophic landslides documented geologically every few 100,000 years, right? Something that was documented back in the 60s by USGS scientist in charge, Jim Moore. So if you have a big chunk of the island collapsing, then you can have tremendous displacement of water, generating large tsunami waves that are thought to be over 100 meters, 300 feet high. So that's where the understanding grew that collapsing volcanoes, particularly in the Canaries, could generate ocean-wide mega-tsunami. And this goes back to a paper from 2001, which suggested that the collapse of La Palma could result in waves 25 meters, 80 feet high along the east coast of North and South America. And that made headlines in the news, which incorrectly depicted a huge wave devastating New York City. So subsequent research, though, is showing a few different things. One, you don't have as many single coherent blocks collapsing very often, whether it's in the Canaries or in Hawaii. Most of them are not that big. There are examples of big ones, but most of them are not that big compared to the giant situations that are put into these models. The mapping suggests that they occur in incremental or piecemeal fashion. That's the standard here in Hawaii as well. In addition, geomorphologists found via slope stability analysis that the potential collapse volume was much smaller than was simulated by 2001 paper. So lower volume, different size, better modeling, right? New modeling shows that the different speed and dispersal of the energy interacts more across long distance, leading to smaller wave heights far away from the sources. So between that better bathymetry, topography, and all that new data, the new estimate of worst case scenario of collapse of La Palma on the east coast of the Americas is 1 to 2 meters, 3 to 7 feet tsunami. So tsunamis are possible, but you really got to take out that mega. There's no mega tsunami going on there. This could be tsunami. So still hazardous, but similar to common storm surge, right? So when you think about hurricanes hitting New York, it can be pretty bad, right? If you're not prepared for that kind of thing. But that's not like you're having any more water than those events. But certainly preparation is always necessary for even that kind of thing. So lack of geologic evidence causes a hypothesis to question. No deposits been identified on the east coast of North and South America of mega collapse, mega tsunami from La Palma. So they do say collapses are common, preceded by a flank instability and perhaps increases the earthquakes and deformation. Frequent eruptions similar to Hawaii, and so everything is fairly stable. Everything is moving and sprawling and spreading at a stable rate. The volcano would have to grow significantly before collapse was likely, and that's where we are with Kilauea as well. Still need to get quite a bit bigger before collapse is likely. If we shift to talk about Mauna Loa, Mauna Loa is big enough where Mauna Loa can have these events on its west side. So that is where we might have the possibility of that parallel in Hawaii. Not from Kilauea, not from the very popularly cited Helena fault system, Helena slump system, but more so from the Lika system on the west of Mauna Loa. So that's the what the history indicates, right? The geology indicates there. So, all right. So there are tsunami generated by explosive eruptions like Krakatau, killed tens of thousands of people in 2018. Hundreds from local tsunami from that small collapse of that small island that's growing within that ocean flooded caldera of Krakatau. So that's certainly possible, but it's not exactly the same situation that's going on in La Palma and Hawaii here. So they talk about other processes, South Flank earthquakes, all that, and so in the end they say that the hypothesis has evolved since 2001, has led to more questions, we've been more refined, and this is a marvelous example of how science is supposed to happen, right? So you put the idea out there, you examine it further, and so you can't just take something that was published 20 years ago and just say, okay, that's how it's going to always be forever. You have to go back and look at the refinements on that data, right? So that's the ins and outs, and I thought I'd go into a little more detail than usual in Volcano Watch because it's a topic of interest to many of our readers and viewers. We'll skip over the Volcano Update here. And we'll come back to an article that is now 7 years old, so also a grain of salt, but not as old as 2001. But most recent, one of the more recent Volcano Watch articles on this collapse of Hawaiian Islands, right? So here they have in this graphic the 17 distinct landslides that have occurred around Hawaiian Islands over millions of years. And the ones on this side over here are the ones that I would be most concerned about today. Mauna Loa is still a big volcano, very steep slope on that side, and free pathway outwards, right? Other ones that have occurred in the past, we've largely passed that phase. We've thought of volcano growth and collapse, where the active volcanoes are still actively changing is more in here. So you really have this Alika section on West Mauna Loa is the one that I think deserves the most attention. But instead, the one that gets more attention is the Helena area right in here, which is actually a subset of this whole South Flank area right there, as we'll look at here shortly. But there are some other Kohala, Haleakala, other areas as well that are interesting to dig into. We don't know a whole lot about these as far as the how they occur in detail, right? So I think that's where a lot of this room for speculation comes in. But we do know the frequency of essentially once every 350,000 years in Hawaii, right? So 3 every million years is the time scale you're looking at right there. So very, very rare, you have a lot of other things to worry about besides that actually being the case. And so, yeah, from Kilauea less so, from Palma less so. Mauna Loa, I'd be more worried about if it starts moving, if that west flank starts moving. We can talk about that possibility of preparedness for a tsunami. More so than usual, because any earthquake can generate tsunami around Hawaii, right? All right, so they do show here, you know, there are landslides across all stages of the volcano life. You know, Loihi has a number of small landslides, even though it's not above the surface, and ones on Oahu and Molokai clearly occurred after islands were established above sea level. So it's not kind of a long window that can occur, but that has to be the case for only 3 per million years kind of thing. So, and not all are catastrophic. For example, Kilauea south flank is moving steadily and slowly 8 centimeters a year, 3 inches a year, with those large earthquakes like in 2018, like in 75, that can jerk it a little bit faster, right? But that's often in that shallower segment of the volcano there, right? So we'll come back to that in a final Volcano Watch we'll talk on here, but they do have this little paragraph right here, right? What then causes large landslides in Hawaii? Models suggest that magma pressure alone is not adequate to produce a massive landslide. You can imagine a scenario, however, in which a large eruption weakens an already unstable volcano, allowing gravity to pull the volcano apart, right? So large eruption in Mauna Loa, somewhere pushing that west flank, that's when you'd be worried about flank collapse the most, I would say, in Hawaiian eruptions at present. So more research is needed, and it can be done not just in Hawaii, but in the Azores, and you might take what's done in the Azores and extrapolate it to Hawaii and back and forth, right? So that's the where this is taking it. And the more recent Volcano Watch article from August 29th, 2019 here, at the time, new research between healing the fault system and large earthquakes. And this is post-2018, post at 6.8. And they're looking at the movement of those fault lines during that big event of the south flank, right? And maybe it's useful to this point pause and go to the cross-section they're going to refer to here and illustrate what is what. So we're looking at here a cross-section of the volcano. The caldera would be up in this direction, over that way, over there. So this area right here in this lighter orange color, that's the Halemaʻumaʻu slump. It's a shallower feature that's detached from that lower level, but it's actually part of that much larger south flank area with a décollement that goes all the way further out. And the way this thing works is this actually slides over this way, and this slides this way, and you end up having this mound of a pile at the end that essentially forces this material to rise upwards. It acts like a backstop in a sense, right? So this fault ends up being curved upwards. So there's no actual way for it to gravitationally just pop down. It has to kind of ride the bumpy slide kind of thing to get up and over those areas. So it takes more than just gravity. And when a volcano is this flat, you can imagine if it was much taller and everything was tilted up, then maybe it slides more easily. And that's why I'm worried about Mauna Loa more in that situation. You don't have such a flatness to it right there. And more of this steep angles, and that's more concerning there. And so that's the pattern. Here's the depth in kilometers, right? So between sea level and 4 kilometers down is that in this particular line cross-section, this upper Halemaʻumaʻu slump detachment. And the décollement is not quite twice that deep, but close to. In some areas, right? Some areas twice as deep, some areas about twice that deep. 7 kilometers, 8 kilometers, 6 to 8 range. It might not be one strand, but like a series of many strands all together in proximity through that zone, like a stack of magazines of papers that's sliding off of its axis there. Right. So now that that's set out, they refer to these areas. So they say here that considering the Halemaʻumaʻu slump and considering catastrophic landslides, what they're saying here is that they do find evidence that there's no connection between those two, upper area and lower area. The slump rides on top of the portion of the island moving with the décollement. It was the décollement that was responsible for the 6.9 earthquake and for the 7.7 earthquake in 75. So that's the south flank movement that's dominated by that lower décollement fault, that deeper one right there. Right? So all slow earthquakes, there's that kind of thing as well. Right? So the overriding rocks on the décollement, so the Halemaʻumaʻu slump, when that thing is moving seaward and slightly up actually, right? So over many thousands of years, the slight upward motion has caused a ridge to form in ocean floor where the fault pushes the surface. In 2003, scientists from Rice concluded this ridge acts as a backstop, making it more difficult for the large Helena slump to slide. This is similar to how a bookend prevents books from sliding down a shelf. That's what that deformation point at the end there actually means, right? So, large earthquakes that can also affect the slump. In 75 and 69, there was not much evidence of movement of the slump itself. They realized that deformations there and realized that only a few isolated portions of the Helena slump fault system moved in 2018 and in 75, mostly by less than a centimeter, less than a half an inch, right? Compared to what we saw was meters of offset in that lower structure. And so the only location with substantial movement during the earthquake was a short segment of previously unmapped fault near the earthquake epicenter. So no motion for the 17 years prior to the 6.9 earthquake as well. So really, the thing's not moving is the bottom line. And if it were moving, that would be a sign that we might worry about it some more as well. But on the Helena polyfront, Helena slump area, because there's been no movement, there is really no legs to stand on being worried about that area. And really, Mauna Loa right now as well, but Mauna Loa more exposed when it were to erupt and its flank were to move as well. All right, so that is all together there, yeah? Taken all together, this observation suggests the movement on a Helena fault system occurs only very occasionally and perhaps only together with the very largest earthquakes, like the 75 earthquake. And even then it moved a very, very, very tiny bit. So they'll continue to monitor for hazard. And that is, as far as I'm concerned, what there is to say on the Helena Poly area in a nutshell there. And we will wrap it up with that in here. If we want to transition to any questions, discussion of that any further, anything you want to add to that, observations from the internet, what have you.
Yeah, I mean, this is just one of those things we always get pop back up in the channels as questions. Anybody that's been around YouTube for a while kind of knows that the hype videos for the Helena slump are real, and there are concerns about landslides, and you went really through them, but it's not there. I think I'm glad that the USGS is putting out more volcano watches on that kind of topics. You kind of have to just to continue to fight the misinformation that is out there on it. It's great for people to be interested in geology and all that and the volcanoes, but you got to be flexible. Just because you hear it on the on a video doesn't mean that that's the real way it is. It takes more verification than that, and sometimes things are slightly wrong, right? And the interpretations matter.
Right.
So
videos are, they're trying to be clickbaity. They're trying to get the most views because that's the model to actually be able to use YouTube to make a living. We use YouTube as a distribution mechanism, not to make a living. We're actually looking for grant funding to support us with distribution information, education, all that kind of stuff, right? But it's not YouTube itself, right? That's where we are giving you guys the fact, a straight up info. We're not looking for the extra clicks. That's because it's sexy. This is kind of the real deal, best we know at this point in time, right? So appreciate you guys and we just sharing that where you see it,
right? And we're just going to be aware that a lot of our stuff is going to be taken by the people that do hype stuff, copied and pasted and made into their own, and probably get distributed to wider networks, just because that's how the internet rolls, and they really know how to work that copy paste button too. So yeah, it comes with the territory. But if you're not going to do the clickbait, and you got to expect it and roll with the punches.
So that said, please like, share, and subscribe our video. That helps put our accounts up. That's what helps us really put the stats up. It helps us with the numbers for showing that we're actually reaching people when we're trying to apply for funding as well.
Right. Well, definitely. We do have another episode of Drones On coming out immediately following this live stream. This one's going to be covering July 15th through 21st. We talk about the ocean entry as it moves towards Poiki and a large really large littoral explosion ends up catching one of the tour boats and injuring 23 people aboard. It's got some footage from that, and we talked about that a little bit, or I talked about that a little bit, as well as going over the surges and changes at Fisher rate. So yeah, check that out. It's only about 9 minutes long, and we'll premiere it after the live stream.
All right, mahalo, Dane. Do you have any other questions we want to touch on here? I see lots of discussion of the earthquakes.
Yeah, there's lots of discussion. I think I got most of them answered in chat.
All right.
Yeah. There was a thing about Mauna Loa. There's a question about Mauna Loa.
Yes,
Two questions about Mauna Loa. Is Mauna Loa doing anything? First and foremost, it was one of the questions.
So no is a short answer. It's not. I can put Mauna Loa up on the screen here for you guys. Mauna Loa update that came out today. Not erupting. No changes. 114 earthquakes, all below magnitude 3, some at upper elevation flanks. No real change in the deformation pattern. We can pop that up here as well. Let's bring up the rates of change. Earthquakes here. Popped up a little bit, but really nothing like we were seeing earlier in the year. Nothing really alarming. You can see really fairly low levels. Maybe starting to do a little more, but not really obvious anywhere. Here's an earthquake map. Anywhere on the GPS, really. So you can see it's maybe starting to show more signs of life, because it's really looking pretty dead for a while. So it's actually showing a pulse, but it's not really seeming like it's going much anywhere, right? The maximum earthquakes 25 per day. It's pretty low here.
Yeah, that's pretty low.
Tilt, let's see.
Green wind.
Can't really see the tilt. Let's pop up the GPS.
Still the question I have is
go ahead.
I'd like to hear just why is it not green from USGS, or what is the threshold for green? Because we got to be straddling it if we're not on it.
Right. Here's a cross caldera distance north to south of the caldera. You can see that our big changes earlier in the year here, big fluctuations up and down, right? And really since then, pretty flat, maybe slightly rising, really nothing like we were seeing earlier. So it's really not changing fast enough to notice anything, to have anything to talk about, to say anything about, really. Which is why we've been light on Mauna Loa recently. Because Kilauea has been much more interesting. Mauna Loa has been fairly unexciting, just kind of a neutral is like the term I've been using for a while. So that's Mauna Loa, not a whole lot going on.
The second question about Mauna Loa was, do you think, I can't find the question right now, but it was, do you think that Mauna Loa is approaching its maximum theoretical height?
That's an interesting question. I don't know how accurate you can calculate a maximum theoretical height. Like, what's the precision on that, right? If you go more general ballpark broad, right? Look at how high Mauna Kea is, and look at how high Haleakala is, and it's pretty close to one of the tallest. Mauna Kea is slightly taller, but Mauna Kea's got that post-alkalic cap stage that fills that whole summit caldera that makes it that extra 100 feet higher. Mauna Loa is basically the same size at its base level. So you would expect that, maybe it can get a little bit higher, but it's, on a grand scheme of things, probably pretty close to its maximum height. Right. This is my intuition. I don't have a source to cite you for on that right now. I think I may have read that somewhere at some point, also something along those lines, but I can't cite that for you right now either.
All right, well, that works. And that does it for me on the questions. There is a Drones On following this live stream, so check that out. And I'll pass it back to you, Phil.
All right, mahalo, Dane. Yeah, we'll just wrap it up here. So we'll be back with you guys one more time next week, unless there's a reason to cut in sooner. We'll keep our every Thursday evening in Hawaii, 5 p.m. Schedule, right? So remember, Drones On premiering on YouTube right after this. In that in-between time, please like, share, and subscribe. I can't tell you how much that matters, so thank you. Thank you guys for that. And until then, you can keep track of hawaiitracker.com. You can go on there if you want to sign up for our mailing list. We're starting to send out less frequent but compilation emails, maybe once a week or so. That kind of include lots of the stuff we're putting up, all of the kind of content, all the different strands of it, so you don't miss anything. And yeah, check on that. It's where we're indexing everything chronologically. It's easier to find that on Facebook. Facebook's got a lot more than other group members submitting content there as well. But please feel free to submit on hawaiitracker.com as well. We would like more activity there, always. So with all that said, check out Jordan's on. Mahalo, Dane. Mahalo all you guys who contributed. Mahalo you guys who donated as well. And we will see you guys all next week. Until then, he's Dane DuPont, Philip Ong. Aloha, everyone.